So this is what our studio would look like, right? And since everybody has installed it, so that's good, so it won't be a problem, right? So now we are gonna try to navigate a bit through our studio for those who don't know it yet. So let me close this and open another our studio window. So this is what you would get when you open a new window from RStudio without any projects or files opened in it. Yeah, so this is what you would get. Something like this. Okay, still open the same thing, but that's fine, right? So on your left side here, right? So this is, so basically RStudio is an open source IDE, right? So you can just coordinate this open source, it's free. So you don't have to purchase any part of it at all, right? And so this part, this is what we call the editor. So this is where you'll be writing your codes and everything. Let's say I just want to say 1 + 1, plus 1, you can just write on it. So this is where we'll be mostly writing our codes. So this left panel. And on the right side, there are actually two tabs, the upper tab and the lower tab. So you can actually navigate through up and down with this arrow. So on the top right, upper right, this is where you call your environment, right? You have the environment, you have the history of what you have done, you have connections and tutorial and stuff like that. And at the bottom, this is where you're going to see your plots if you're making any plots. And this is where you're going to see any files that you have in your working directory and the packages that you might need or you have already. Right, so this is just the basics of RStudio. And so now there are various things that you can do with RStudio. And one of the things that you're mostly introduced to when you are dealing with a new language is how to use it as a calculator. So as I've shown you here, I have 1 + 1, it gives you 2, right? So now observe what happens if I just say 1, then plus, and then I say enter. So instead of making this arrow now, it makes a plus, right? So this tells you that root is actually waiting for you to finish your command that has started already. So I'm just gonna say another one, and then now it's satisfied, and then it gives you the result. So this is one of the ways that you can actually use it. And another cool thing about it is that it has built-in functions, right? So you can, let's say we do the log of 10. So you will notice that as I start typing, you're gonna get this tab right here, which shows everything that starts with log. And you can choose whichever one that you are interested in at the moment. And when you navigate over it, it's gonna tell you what it means, what it wants, the arguments, and the output. So in this case, in terms of log, the first one, you have input X, and also there's the base, right? And this tells you the output of that. So let's click on log, and let's say log 10, and then I press enter, and then you get your answer. So you don't have to, so you can just use any function that you're interested in here. So you can also have another one, let's say exponential. Please feel free to stop me along the way because I don't think I can see your questions or comments. So if you have any questions or comments, you can just unmute your mic and I'll answer to that. So another one, we have the exponential function. Again, when you navigate through it like this, you can see the inputs and this short description of what the function does. So I can just say exponent of 3, enter, and then you get your result. Is everybody on par on how we can use root as a calculator so far? Thumbs up if you guys are okay. Okay, great. So one important thing that we're also going to be using, especially when we're going to be analyzing data, Is someone saying something?
Good.
Okay. Okay, I'll continue then.
Oh, sorry, was it a question or? Iofa, I think, maybe unmuted.
And probably they didn't realize that they unmuted.
Yes.
Do you have a question? Okay, guess not then. Okay, I'll continue. So one of the important things that we will need for this lesson later during the day is the introduction to variables. Of course, if you've used Python or any other programming language, you know this already, but for those that don't know, so basically a variable it's like you have what you say, like a name or a letter associated, and then you have a value associated with that parameter essentially. So let's say I have X and I want my X to hold the value 2.
Yeah, I'll I need a new supplier or somebody.
Pardon, are you saying something?
These guys are just disappointing. It's constantly like this.
I'm not sure if this directed me because I can't really hear him properly.
I do. I'm constantly on their case, and
I
right
think
now
it's
I'm just
on the
looking
phone.
for person who can
I
assist
think
us.
it's on the phone.
Okay,
Can you
I'm
please
just going to mute.
just
Yeah, I'll
yes,
just mute
please
him.
mute him for me. Thank you. Yeah.
Okay.
So let's say we have this variable X and we wanted to hold the value 2. So this is going to be the convention to make it hold the value 2. So instead of an equal sign compared to Python, so I'll be making a lot of comparison to Python because most of the people here actually know Python. So I'll be making a lot of comparison with that. So instead of an equal sign, we make this less than sign and then the minus, kind of like an arrow if you look at it in that way. So X holds the value 2. If I say enter, there's nothing that's happening, right? Because I didn't tell root what to actually do with this variable, right? So one thing that I can do is I can just print it. So if I say X, it's gonna give me the value assigned to X, which is 2, right? So now, if I try to do this, so X and then X plus 1, what do you think the value for this will be? So now I redefined X. So what do you think the value for this will be for this line? Anything in the chat so I can just speak out? Any takers? Did you guys open your art studio? Because I think it would be much better if you kind of like code along with me and be able to see what I'm doing from your own side.
There's one guest in the chat. 2 guesses in the chat.
Yeah, what?
So we have 3 and 3.
Okay, 3 and 3, thank you. Yeah, so if you press X, then you're gonna get 3. The reason why, it's remembering the initial value that you had for X. So X was 2, and then you're adding 1 to that. So when you print it, it's gonna be 2 plus 1, which is 3, right? So continuing so far, let's go to what we call vectors, so vectorization. So you might know, like in physics and in maths, a vector is just a parameter that has magnitude and direction, right? So in root, it holds a different meaning. So in root, basically, it's just a set of values in a certain order of the same data set. So the keyword here is has to be in the same data set or data type. So if I make this, so 1 and then colon 5. This is what I expected to get, right? So what this is saying is that it's telling root to print anything from 1 to 5, whole number, anything from 1 to 5. So it starts from 1 until 5, right? So this is what we call vectorization. So now if I make a command like this, and I'm putting 2, and then 1 exponent, 1 is to 5. This is what I would get. So essentially what this is saying is that we have 2, put it to an exponent of 1, and then 2 to an exponent of 2, 2 to an exponent of 3. So basically 2 to an exponent of this whole range. So that is why we get this varying ranges in it. And this will become more apparent as we go, more useful as we go through the whole session, the whole workshop, right? So
I'm so sorry. I was just wondering, is it possible to zoom a little bit in the console? Because at least on my side, it's quite small. I'm not sure if it's
let
possible.
me try. How about now?
Yeah, I think that's a lot better. Okay, thank you.
Okay, thank you so much for that, Amy. Yeah. So this is what you would get, right? So let's say now I have a variable again, and we call it mass. And it holds this value, let's say 5. You can say 5 kg, the units don't matter, right? And you say age, and then this holds value of 2, right? So now my question is, how can you write an inequality to show that the mass is actually greater than age and make it true? If you don't understand the question, please let me know, and then I'll try to rephrase it. Well, let me just do it as that, and then we can look at my activities later on. So if I say mass is less than age, we get false, right? This is because the value of mass is 5 and the value of age is 2. So 5 is definitely not less than 2. So that is why we get false, right? However, if we make this, let's say we make mass is equals to age, would also get false because 5 is not equals to 2. So all these inequalities are also essential when you're going to be like studying the data that you have and trying to make comparison, especially in a statistics way. So we'll see that later on in the day, right? So now the starting point of where I want us to be now is how to create a project and to create a file. So this is what we'll be using for now until we do the whole data analysis. Let me try to share this. I'm not sure if people have the data that I want us to analyze. Let me just try to share this link with you. Or you can download the data so long. It's not gonna take long. Copy.
Did you share the link already, or are you just sharing it now?
I just did.
Okay, yes, yeah.
Yeah,
okay,
so
great,
this will
you.
be the Cody MD for the day. And then if you scroll down, you can see to do before the workshop, and then can be able to download the data for this lesson. Is everybody there already? Were you guys able to get there? I'm sorry, I can't see chairs or anything.
I have the data.
Oh, you have the data. Anyone else who needs time to download the data? Who needs more time to download the data before I
just-
can?
Yeah, I'm just downloading, so can you give us 4 or 5 minutes?
Oh, okay.
Thank you.
Right.
Do we have to extract the data or leave it in a zip folder?
Please extract it to the folder that you are going to be working in.
Okay.
Yes.
I downloaded the data.
Okay, I'm still waiting for others to load. Is everyone still downloading? Please give me a thumbs up when you are done. Okay, so 2 people done, 3. So I think we are all done. Yeah. So I'll share my screen again. Okay, I think you can see it now. Yeah. So now we're gonna try to navigate how to create a file and a folder, right, where we're going to be analyzing our data. So now you have your data and we're going to put it in the working directory, right? So in order to create a folder, a project we're going to be working in, we're going to go to the file tab there at the top. Can you see my cursor?
Yes, you can
Okay.
see.
Yes.
Okay, great. So I'm going to go to the file tab and then new project. And save. Well, I don't really need this anymore, so I'm not gonna save it. So it's gonna say new project. And then I'm gonna see another tab coming. Yes. So we have this 2 options. So you can have a new directory or an existing directory. Right. So if you already have a project where you've been working in, you can just use an existing directory. So I'm gonna say new directory. And then we want to have a new project. So I'm gonna click on new project. Right? So, and then you can browse the subdirectory of the project. So I want it to be on desktop day 3. I'm gonna choose that. And then I want my directory name to be day 3. You can choose it whatever that you want it to be. Let me say day 3. And then from there you can just say create project. So now it's going to switch to the new project that we've just created. So remind me later on this. Right? So this is where we are now. So under files, this is where we are. So node to the extension of the new project is .r and proj. Right? So this is the R project. So now we've created our project. Now we need to create a file, an R file where we're gonna be coding, right? So we're gonna say file and then new file. And then we have the R script. So this is where the script that will be putting all our codes and commands, everything that we're going to be doing. And the reason why we are using the R script is because we are going to be able to save it and use it for later on or even share it. I mean, we can do the same thing here on terminal, but once you code it, then you can be able to save it and share it or do something like that. So we'll just use the R script command. So does everybody get this when they choose the R script command?
Yes.
Okay, great. I'm hoping no one is having trouble getting to that part. So this is what you're gonna be getting. This is where our editor is, and then we'll be making our commands and everything here. All right. So another thing that you should note is you should always save the script. So it's not automatically saved. So after typing something, right, it's going to be highlighted in red there at the top, right? So it means that you need to save it, the current document. So if you had additional documents that have been opened, then you can save all open documents. So only have one. So we just need to save the current document. So I'm going to click on save current document, or I can just Control S, whichever one you prefer. So we are still under the day 3 project and we need the file name. So I'm gonna say day 3. You can call it whatever that you want, right? So I can either leave it like this and it's automatically gonna create an extension which is gonna be .r, or you can just explicitly write .r, so it doesn't matter. You can leave it like that or explicitly say .r to show that is an R script. And then you say save, and that's what you have there. So you'll see that at the bottom, right there, you'll see that you have the day 3 project and your R script represented by the .r. So this is where you're working directory, right? And you'll also see that my data is also not here. So it means that I have to bring my data into this folder. Otherwise, every analysis that I'm trying to achieve won't be able to happen because because it's not in the working directory. So now we've established on how to create a project and create a file. I hope everybody didn't have much problem with that. If you did, please let me know and then I'll try to assist. Right? So another thing that you need to know is how to run a line or run a command or execute a command, right? So let's say I say 1 + 1. In order to run it, see if I say enter, it doesn't show me anything. So on the terminal, you're supposed to see the result of my execution. But if I say enter, it doesn't show me anything, right? Because I need to explicitly run it using the run command here, by run, or you can say Control Enter on that line. So your cursor should be anywhere on that line for it to run. Then say Control Enter, and then you're gonna get the result for that. So you can either say Control Enter or say run. You still get the same thing. And then now, suppose you want to run multiple files, multiple lines. X is equals to 2, and then Y is equals to X + 1, right? And you don't want to keep continuously running this firstly and then running that second. You just want to run everything at the same time. So you're just gonna highlight everything, then Control Enter, or highlight everything and run. And then if you want your result of Y, you still do the same thing, Control Enter, or just run. And it's gonna give you the value for Y, which is 3. Right? So that is how to run just one line, or you can run multiple lines, right? And again, it's gonna highlight to be read when it's not saved, so you can just save it, or you can just click Control X on your keyboard S, and then it will be saved. So always remember to save your code. So I don't need this, I'll just remove that. Right. So these are just the basics, the introduction to root and everything. So now we'll come to the data analysis. Any questions so far? Okay, no questions, great. So in this, for this part, we are gonna be studying patient data. So let me try to open this. So this is where my data is. So it's not in the working directory. Can you see that? So my folder is here, but my data is here. So I'm gonna copy this into the folder where I'll be doing my analysis. So this is the data. So if you open it, you'll see multiple CSV files, right? So, and then if you click on one of them, so let's say information 01, you're gonna see CSV data, kind of like an Excel. So it's gonna show you like in an Excel format. Just a bit of time to open. Yeah. So I already have it on my working directory then. So now it is opened. Yeah, so this is what the data looks like. You have 60 rows here, and you have 40 columns. Right, you have 40 columns. So the rows represents the patients with inflammation, and they've been like taking medication over 40 days. So from A to there, this is over 40 days. So this is what the data looks like in CSV, right? I mean, you can still do the data analysis in Excel, like maybe make plots of whatever that you want regarding the data and the patients. Let's say maybe you want to know the progress of patient number 60 over the last 40 days. You can do that with Excel. However, with the advantage of using Root is that you can execute the same thing for all the patients, and your program will remember what you have done before, and it's going to be able to execute the same thing to all the other patients. So you don't have to do the same thing over and over again. So in Excel or CSV, you might want to plot this patient recovered over 40 days. And a few days later, you want to plot the different patients. So you're going to have to click on them, do the plot and everything. So with Root, you can just create a function that takes the data of the patients over the certain number of days, and then you can make plots, you can standardize statistics and everything like that. So it saves you a lot of time and allows you to do a lot of tedious work. So this is what we'll be going through. So now I'm in my working directory. Does everybody have this, like the project, the script and the data on the same working directory?
Just the data file, how did you add it to RStudio?
Oh, I didn't add it to RStudio. I added to my working directory. So this is where I had it. So this is on my desktop.
Mm-hmm. No, but
Yes.
I'm talking about 3 files. I only have 2 files on the files on RStudio. I have the R project and the one ending with R. Yeah, those 2.
Okay. For
But
you to add your data, just go where the data is. Right. So I had my data here, and then I copied it into data, which is my working directory. So I have the data again. So automatically it's gonna show on RStudio.
Good. Thank you.
Yeah. So you should be able to see everything in the same folder. So is everybody okay? Or was it only everybody else is okay? Okay, no complaints so far, so we'll get working there. So basically this data includes patients who have been given new treatment and they're trying to see their recovery over the 40 days, right? As I've shown you on the CSV file, right? So we are gonna create a project. So this is the project that we've created already to make our analysis and study the data. So the first thing that we are gonna be doing is to load the data. So we have the data here. So now we need to load it and be able to read it, right? So try to code along with me and see if you have any problems, and try to see if you can actually do it on your own. So what we are gonna tell our students is that we need to read the data. So as I told you, once you start typing something, it's gonna give you everything that starts with what you've typed already. So now I'm saying read, so it's giving me all the options with read. So the format of my data is CSV. So I want to read a CSV file. So I'm gonna hover around this one, the first one. So here you'll see it needs the file, the header, the separators, the codes, the small. So there's a lot of stuff, but build onto that as we go on. So I'm just gonna click on it, right? So I'll not be using each and everything that's there. I'm just gonna use the ones that we need the most, right? So obviously we're gonna need the file name, right? And if you go here, you can click on the data. So we'll start with looking the first on the information 01, right? So the file name in this case, so we have file, and then again, if you did this, it says file, and then it shows you what it does. So that's the cool thing about RStudio. Instead of just using the command with RStudio, you can actually get to have a feel of what the command actually, or what the file or the everything that it has, like the functions and everything, the explanations. So it's going to be easy for you to actually use it. So you just click on it and then type the file name. So the one you're going to be looking at for now is inflammation. So inflammation dash 01.csv, right? So that is what we're gonna be using first. So before I continue, what's missing in this line?
I think maybe
for
the double quotes.
Yes, the codes. So we are missing the codes. So we need to put this and then we put that. So this is a string, right? So we're telling root to read this CSV file. So we also include the extension, right? So let's try to run that. We get an error. Why are we getting an error? Why do you think are we getting an error? It says we cannot open this file. There's no such file or directory, but we can see that it's here. Why are we getting an error?
Maybe because the route to the file is not yet clear to R. Maybe we need to add more detail.
Exactly. Remember, this is where we are. So this is where the script is, right? And this is where the data is, inside data. So root can get the path of this file because it's inside data. So I have to also include this data. So I'm telling the script to go inside this data folder. It's gonna be data, and then don't forget a /, and then information. This should be fine. No such file or directory. What would be the problem now? Information, did I type it wrong? So we are inside data, and then inflammation.
Maybe.
Oh,
maybe
it's this. I wrote a 0. Instead of a 0. Yeah. Now it's fine. Is everybody on the same page as me? Please stop me. Don't hesitate to stop me if you have any troubles. You see how you can easily make mistakes with this. I wrote a 0 instead of instead of a 0. So this is what the data looks like when you print it here.
Sorry.
Yes.
On my window, I can only see 3 columns instead of the many that you have. So I'm not sure if there's something
Oh,
that
you can see
on
3 corners of the data.
no, like I have 3 columns of the data, like numbers, just only 3 columns.
Oh, probably your
Yes.
download wasn't successful and then partially downloaded or something. What about when you open it in CSV? When you actually open the data in CSV?
Okay, let's see.
Try to open that.
Just a minute.
Okay. I hope everybody else is on is not having like trouble opening the file.
Okay, on the CSV, it's fine. It has almost
Another
all the
thing?
rows.
Then
Hi, Nazim Monanata.
I think it's just wait, can you
Maybe I
please share
can.
screen? Is that on your console? Does it show only 3 columns? But does it also show dots, like the 3 dots to show that it continues?
Let me just share my screen.
Okay, let me stop sharing mine.
Okay. So I'm here. This is my data over here, and this is the code I'm trying. So I'm not sure why
Oh,
everything
it
is
still
missing.
has that. It just says it omitted 34 rows.
Oh, okay.
They're still there though.
Okay. So how do you
Yeah.
get it to show?
And it probably has to do with your computer, like the processing or something. Because it does show that it has everything, just that it omitted the rest.
Okay.
Yeah, I think it is a computer thing.
Oh, is it because maybe I'm using Windows?
I wouldn't really know, honestly, if
Oh,
it's because of Windows, but
No, I
but
don't.
everything is there. It's just telling you that it omitted some of the rows, but the rows are still there.
I'm using
okay.
Windows, and it.
And showed everything.
Yeah, showed it.
Can you please
Okay.
scroll up on
This
your
is all I have.
console? No, I'm on
Okay.
your console. Yeah.
No, this is all I have. There's no scrolling up. Oh, there it is.
Yeah.
Oh, crap. Sorry. Okay, I see it.
Yeah. Okay,
Okay.
cool.
All right.
Okay.
Thank you.
All right. Share my screen again. Sure. Yeah, great. Yeah, so this is what we have, right? So we have this, the different rows in the columns. I mean, yeah, it doesn't look so neat compared to CSV, but you understand, at least you have an idea of how the data looks like, right? So now let's try to do the same thing again, but including that header command that we saw earlier on. So in order to include another argument, you just say comma, and then when you type header there, here it is. Just click on it, and you're gonna say false. And then you just click enter, right? So what this actually means, this false part, is it indicates that the file doesn't have any column headers. So we saw that the file doesn't have any column headers. So if you look at the first line that we printed, it tries to include columns for it, like root tried to include columns for it. So now we're telling it, no, you don't have to, you don't have any headers, so we're just gonna place it at false. So this is what it does. So this is fine. Right? So now we're trying to load the date.
Yeah, so why did you copy the code and put it again? Is it easier? Wasn't it easier to edit the first one.
Yeah, it could have also been there. It's fine. I just like to keep track of what I'm doing.
Yeah, but
Instead
if
of
you
just
if you do it, it's fine, right? There is no problem on
yeah,
the
there's no
result.
problem. Yeah, it's
Yeah.
just my personal preference.
Uh-huh.
Yeah. Yeah, I mean, if you've just edited this one, that's fine. I prefer to keep track of what I'm doing and the changes that I do. Yeah, so it
Mhm.
doesn't matter either way.
And
Yeah.
if you want to run this code, you need to highlight everything. Otherwise, it will be some of the commands will not understand that change happened at the earlier codes.
If you need to run this one, you can just only have your cursor on any part of this line. So you don't have to rerun this one because already run it.
Mm-hmm.
Yeah.
Okay.
So you can just have your cursor anywhere here.
Good.
Yeah. So now let's try to include, let's say now your data is not like this, right? It's not separated by columns so neatly like this. Let's say now you have this data. So let's go back here on the data. So let's say you have a text data. So if you can try to open the Comedec text file. So let's say now your data is in a text file, right? And then all the entries are separated by a semicolon, right? And you still want to run this without having to edit each and every line. Let's say it's a lot of data and you can't remove all the semicolons and everything. You can still be able to read this text data using the CSV read command. And the way you do that is, let me go back. Yeah. Again, you're going to still use the read.csv command, right? And you're going to tell root which file you're trying to look at. So in this case, this is the file that I'm trying to look at. There's comedec.txt. But don't forget quotation marks, so it's comedec.txt. Right? So see if I do this, let me do it again. So if I do that, it reads it as we saw in the text file, right, with all the semicolons and everything. But it won't be so easy to deal with this. Like say you want to plot something, or you want to perform some mathematical function, or want to do statistics on this data. So we still want it to look like this, right? So we have to include more commands in here to tell root what to do with the data. So we're going to tell it to separate the data using the semicolons, right? So where it sees a semicolon, it should make a space, right? Separate it. So in order to do that, you need to include the separator. And then, as I told you, when you type, it tells you what to do, right? So you just click on it. And then what is it separated by? In this case, it's separated by semicolons, right? And another thing that you can include is the decimal. So depending on where you are, your decimal might be a full stop or it might be a comma, right? So if your decimal is a comma or full stop, that's fine. So just click on it. So mine is a comma. So I just have that, and then you should run it. And then now your data looks a bit more cleaner. So you can actually do a whole lot of stuff on this that you can do mathematical operations, you can plot it and stuff like that. But with this one, it's hard to actually do that. So this looks more manageable, right? So instead of doing this whole part here, you can also just say read.csv, and now we can choose CSV2. Right, so it does the same thing as including the separator and the decimal. So if you just say CSV2 and then include your data that are trying to read without anything else, and then you run it, that's the same thing. So this is what we got from the last command. And this is what we got from the first command. So it says v2 data automatically is able to read a file with all the separators and the decimals that you might have. So now we're able to read our data. Is everybody on par with this?
Sorry, I didn't follow the last part of the DEC. This pause, you said
DEC, which part?
no. The end of the read CSV, the command file.
Oh, number 4.
Yeah, number 4. The end of it.
Oh,
Use
oh,
DEC.
DEC, yeah, the decimal.
This
So
is yeah.
yeah, are you using a decimal as a comma or decimal as full stop? So I prefer decimal to be a comma.
I didn't understand why we are using. What's the reasoning of using decimal or adding this to the code?
So because now in a data you might have decimal as a full stop or as a comma. So it's just a personal preference. You see, it didn't even change in the data itself, but I'm telling it that for my decimal, I prefer a comma instead of a full stop, even though it didn't change. It's just how my preference. So it doesn't really do much, just a preference thing. So you don't need to use this if you feel comfortable with the decimal annotation that is being used. Yeah,
That's
thank you.
good.
Yeah. So now we're able to load our data. So let's try to assign variables to our data, right? So in the last few minutes, we did where we assigned X to some number, and we're trying to read that number as equals to 2. And then we try to print that. Right, so X equals to 2, and then when we print X, it gives us 2. So at any point in our code, we can try to use X, right? So we don't have to always define X is equals to 2. I mean, this one is a simple definition, but now imagine you have a lot of data like this, and you are gonna consistently like writing this, like every time, like having to write, oh, read this file, do this, do that. So to save time, you don't want to do that. So we're gonna introduce variables, the ones that I've introduced before. So let's introduce a variable for the data so that you don't have to type this part over and over again. So let's say the data is just that, right? And then we say that is given by this. So this is the value of our that variable, right? So also let's include a header to be false. So we're telling it to know that it doesn't have any columns or any headers. So when you say that, automatically it's gonna print the data that you have. It's gonna print the data that you have. So instead of having to write the whole thing over and over again, you can just call this data using the variable that. It becomes easy, especially in a code when you like have a lot of stuff, it becomes easy to manage, right? So another thing that we can do is actually read what's in the file, see what's actually in the file, right? Basically, we can manipulate the data and see what's happening in them. But let's start with determining what type of class are we dealing with here. Yeah, right. So by class, it actually tells you what type of object you are dealing with. So if I say class and then I click on it and I include the variable that, then I run it, it's going to tell me it's a data frame. So you can see that inside that there's actually data. So if I say class 2, then I run it, it tells me that it's numeric because 2 is a number, right? And then let's say we need to determine what this is. let's say, what can you say? And it tells you that boy is not found because we had to make a variable of this first. So already this knows it because we've already have a value for that. And this is just a number. So this is one of the things that you can look out for. And another cool thing about other programming languages is that when it gives you an error, it tells you what the error is so that you can easily be able to fix it. So it doesn't just leave you hanging, it also tells you what caused the error. And you can, don't forget to save your file. And now let's try to look what's in the file, right? So let's do this. So I'm telling Root to look at that, and then we have this square brackets, and I'm saying 1 and 1. So the first one here, or let me say 1 and 2. So the first one here before the comma, it shows me the row, so the row number. So I'm telling this command to look into this data, right, and look at row number 1. And then this represents the column. So I'm telling you to look into row number 1 and column number 2. So if I print this, it's gonna give me 0. And so remember, it's row number 1, column number 2, and this is the value that we have here. So it is indeed 0. So essentially you can look at any point of the data using commands like this. Yeah. So it's 10 o'clock now. We can take a few minutes, 15 minutes, and we'll come back at 10:15. Any questions before we take a break? Let me stop sharing so that I can see. Okay, Amy's good. Okay, no questions so far. That's fine. We can take a break and then we'll resume at 10:15. Thanks. Because I'm not really... Thank you. Yes, can you please say that again?
Okay, I got left behind when we're dealing with the text file. I kept getting an error when I put the separation, the semicolon separation.
Can you please share your screen?
Okay. Okay, so this is where I was left off, right over here. So there is this error, unexpected token.
I see what's happening. You have an additional, what is this, the symbol? Is it apostrophe, yes.
Come on.
Quotation mark, thank you. Yes.
I still have the error though.
Yes, separate, you need a quotation mark here after the text, txt before comma.
Here.
Yes, that should be fine now. So the colors also like tell you what's happening, because you saw even the separator was like in gray, in green. So it was telling you that it was inside the quotation marks and it's not supposed to be inside the quotation marks.
Or also the quotation mark should, the closing one should be before the separator and everything else that comes after.
It should be
Especially
before
after.
it should be before the comma that separates the next argument.
Oh, okay.
Yeah.
Thank you.
Pleasure. Anyone else? Are we okay, guys? Right, camera. I think you can see me now. Can you see me now properly?
Yes.
Okay, great. So if there are no more other questions, let me share my screen and then we'll continue. Okay, so going back to our data, So basically manipulating data, right? So I showed you that the data has 60 rows and 60 columns. You don't have to take my word for it, but we can try to find out if that's really the case by using the dimension command, right? So if you hover over a dimension, it tells you the dimension of the object. So retrieve or set the dimension of that object. So if I say the dimension of our data, then I run that, it tells you 60 and 40. So the 60 is for the number of rows, and then the 40 is the number of columns. So we have 60 patients and 40 days where they have that treatment, right? So let's see what more can we do with this data, right? Like the simple stuff. So let's read the data file again. So don't forget your brackets, right? But now, let's see what this does. So another bracket, because it's supposed to be square bracket. Let's see what this does. So remember, you still need your rows and your columns. So I'm gonna say comma and then another C, and then I'll tell you what this C does in a few seconds as we go along. And then I say 1 and 2, and then 3 and 4. And then let's see what that prints. So this is what it prints, right? So it tells me that for the row, which is separated by the comma here, for the row, look at the first 2 rows only. So row 1 and row 2. And for the column, look at the corresponding columns, for the corresponding data for column 3 and 4. Right, so basically you're just looking at specific columns and specific rows. However, there's an easier way to do this to reduce confusion, right? So instead we can just say the data again. And let's make this 3 so that we make it to be a range. Then let's make this 5, and then this is what it prints. Yeah. So what this is saying is that print for this row, print row 1 and row 3, right? And for this column, print column 3 and column 5. So it doesn't print a range. So it doesn't print from column 1 to 3. So do you see the difference? When I ran the first command, it only printed 1 and 2. When I ran the second command, it only printed 1 and 3, the rows. And the same thing with the columns. It only printed 3 and 4 for the first command. And for the second command, only printed column 3 and 5, right? So this is when you specify which rows or which columns that you want to look at, right? So let's see what happens when I do this. 1 and 6. And there's no comma anywhere here, right? So this is what it does. So automatically, when I say, look at this data, and the range should be from 1 to 6. So this is what it means. The range of this is that of the column, not of the row. So we have the 6 columns, so represented by V1 all the way to V6, so 1 all the way to 6, and this column represents the range. So you need to print everything within 1 and 6. So we are represented by these columns. And with the rows, it prints out everything. So it prints out everything within this range. But sometimes you may be in a case where you actually want to specify the range of the rows that you want to print and the columns. So the data that you want to look at, you might want to specify it, right? So you can still be able to do that. So let's say you want to look at the first 5 rows and the corresponding columns for that. Let's say the first 6 columns. And this is what you have. So now what you're telling it is that look at the first 5 rows. So from 1 to 5, right? So the column again represents that range. So this is for the rows. And when you come to the column part, we are saying, look at the first 6 columns corresponding to that data. So now you have this columns corresponding to that. So see how this is different from that. So this one is a range, and this one just specifies certain ones. So it doesn't provide a range, just says we're looking at this row 1 and row 3 and column 3 and column 5. So that is the distinct difference between the two. So I want to know, what does this look like? So if I have this, or let me. So what does this look like? The last line, line 19. What does it give you when you run it? So when you run this command, line 19, what does it give you? Anyone? Any
It will give
takers?
you the 60 rows with 6 columns. All the
Yes. Yes, so when you run it, it's still the same as this one. So it's the same as this. It gives you the same thing. And another thing, in case you want to make comments or make descriptions of what your code does or your command does, you can put this symbol here and then write whatever that you want. So it's not gonna, root is not gonna execute whatever comes after this hash symbol. So sometimes probably in the future, I want to use this complicated code and you will still understand what's happening in it. You can just make comments using this hash and then it won't be executed. So this is the same as that. I hope everybody's on par with that. If not, please let me know. So we can also try to read the data from certain row. Let's say you're interested in a certain patient that has the treatment for inflammation and you want to see the progress over this 40 days, right? Let's say you're trying to look at patient number 3. So this is the command they're gonna put. So you're gonna say the row of that will be 3, right? So a certain patient, and you wanna see the progress over the last 40 days. So you don't have to specify 14, right? Because it's gonna give you the data for all the days. So this is what it's gonna look like. So this is 40 entries, 40 columns for row number 3. So the progress for patient number 3 for over the 40 days, right? And you can do similar thing with the days. Let's say you want to look at a certain day, right? And see how the progress of all the patients has been. Let's say day 6. You can still do the same thing. So this would be column number 6, and you're looking at all the rows for that day. So you can also do the same thing with this. So this is how you can actually manipulate the data and extract some of the information that you want from it and leave out the rest that you actually do not want. So you can still use the whole range portion, right? Let's say for this patient number 3, you want to look at the progress for not the full 40 days, but for a certain number of days. Let's say for the last few days. Let's say from day 20 all the way to day 25, right? And you run that. So this is what you have. And you can still do the same thing with the number of days. Let's say for day number 6, you want to look at certain number of patients, right? And let's say you want to look at patient number 10 all the way to the patient number 15. And you can be able to get the data for that. So this tells you that you're looking at this rows and this column. Is everybody on par with that? Please don't hesitate to ask questions as I go along. So if you run this command, what does this give you? Line number 24. So I'm calling out the data and I have the square brackets and I only just have a comma without any entries in between. What does this give you if you run it?
All the information.
Exactly, it gives you everything, right? So it gives you everything. So another thing that we can do is to use what we've already been provided from root. So if you see the columns that root has given us, like the headers that it has provided for us, we can also use those to actually extract or manipulate our data. So we can have this, and then this would be the $sign, right? And see, the moment I put the $sign, I don't get anything regarding a $sign. I get a total different thing, right? I get all this V1 until V14. So what does this tell me? It tells me that I can choose any column that I want to read data in. This is what the $sign is for. I can read any column that I want. Let's say I want to read column number 21. Then I print that. So this is the data for column number 21. So instead of using this convention to write, to include the data for a certain column, you can also use this if you know which column you're dealing with. Right, if you know which column you're dealing with, then you can just write this convention. So that's fine. And you can still do the same thing using the square bracket, so it doesn't really limit you. So I can still say V21, right? But notice this, it gives me an error when I say V21. I mean, we know that V21 is here. That's what we know. But it gives me V21. What do you think might be the problem?
Missing the $sign, I think.
That's another thing, but no, this time you don't need the $sign. So they're saying that the object V21 is not found. So we need this. The quotation marks, that's what we need. So initially I can just put a $sign, but if you're going to use the standard conversion that we've been using, you need the quotation marks to include this. So this is column number 21. So this, and this, they're all the same. And then we do this, and then column number 21. They are all the same. So this three, it's 1, 2, 3, they're all the same. So you're not limited to only one standard convention. So whichever one that you prefer, you can actually continue with that one. So you don't have to stick to only one thing. So that's the cool thing about our root, because it doesn't have only just one standard convention. Just use whatever that you're comfortable with and whatever is easy to deal with when it comes to your data. So let's continue. Don't forget to save your work. So now let's come to mathematical operations on the data, right? Let's say you want to sum some of the data, you want to do some statistics, some of the data, or you just want to get something on a mathematical level with the data, right? So one thing we can do, remember we had the date file. But now, let's say you want to look at a certain patient or a certain day. One thing that we can do is to introduce variables, right? So that you don't have to do this conversion all over and over again. So you can introduce variables, right? So let's say we want to look at the first patient. And let's say it's patient 1. You can name it whatever you want, whatever you're comfortable with. So we're telling it that patient 1. So you need to go into the data file. So that's how you have that. You need to go into the data file and read everything about patient 1. So what do you think the command should be inside the square brackets regarding patient number 1? So if you need all the information for all the days for patient number 1, what do you think the command inside the square brackets be?
The first row for all the columns.
Exactly, the first row, this should be. So patient number 1, and then for all the columns, right? So this is the data for that. So now let's say for all the days for patient number 1, you want to get the maximum value. So this is what we have, right? So we can call the max function. So remember, I told you that root has, RStudio has inbuilt functions. So you can actually call the maximum function to determine the maximum value instead of having to go through the data itself and try to see this, which one is the maximum. So you can say max, hover over it, and this is what it tells you. It tells you the returns the maxima and min of the point. So depending if you use max or min, will give you the maximum. Is someone saying something, Ziad?
Oh, sorry, I mute myself. I just joined.
Oh, okay, it's cool. So we click on it. So what do we need the maximum of? We need the maximum of patient 1. The data for patient number 1, right? So that is going to give us the maximum value, and then you just run it, and then you get 18, right? So if you go here, and this is where 18 is, if you go to the CSV file, I prefer to look at this than to look at the data in the RStudio. It makes it more easy for me to see compared to being able to see this. So the maximum value there is 18. So you can also verify that you're looking at your data, right? I mean, you can do the same thing with all the other patients, right? So now, let's now assume that you don't want to look at the maximum a point or maximum data for patient number 1, right? Instead, you want to look for a certain row or column, you can still do the same thing. So let's say, then I have 1, and then you'll see what happens. So instead of running one line, I can run the whole thing. And then for column number 1, it says that the maximum is 0. Is this true? Let's check. So this is column number 1, presented by A, and all the entries there are 0. So indeed, the maximum is 0. So you're not only restricted to rows, you can also do columns, right? So we can do a whole lot of that. I can even determine the mean for that. Let's look at a different column, which is different row, which is non-zero. Let's say 21. And then you get that the mean is that, and you can also reverse the columns and the rows, right, to get the mean. So not only limited to that. So now I want to ask, let's say we have this, the maximum, and we look at the data. And how good is that it shows you the data. So the moment you say data, it shows the data because already that's a variable and we assigned it to the data that we loaded earlier on, right? So if you say the maximum of this data, of course you need some entries. I mean, you can just say the maximum of just this data. You need some entries. What are we looking at? What are you telling root to actually look at? So let's say you're just telling it to look at column number, let's say 21 again, since we know that there's some entries in the sub to the brackets. So this is there. I'm hoping the noise is not too much. I'm in the office and I'm sharing offices with someone. Is the noise okay? It's not distracting.
No, I think it's fine. It's very quiet.
Oh, okay. So this gives us the maximum for data for this column, right? For column number 21. I mean, you can also do this to make it seem a bit so that you can understand. And look at this. We get this, I need another bracket there. And then we get the maximum for column number 21, right? Then you can do the same thing with min. So my question is, how can you write this in a different way using the conversions that I've already used here in this? How can you write number 31 using what we've already established in number 24 to 26? So you can use any of the ones that you want. Can you try running that using the different ones, except for what I wrote here? So try to use what you established in 26 and also in 24 and tell me if you get the same thing as I do. You guys get the same thing? So run the same line, number 31, but use the conversion in 24 and others can use the conversion in 26. Do you all get 20? Is the maximum for this line? Or we get something different? I mean, it should be the same thing. If you do maximum and then you use this, don't forget your brackets. It should give you the same thing, right? And that should also give you the same thing if I were to use the command in number 24. So it doesn't matter which conversion you use, it still give you the same thing, right? So you can do the same thing with minimum function. And then we have that, right? And now let's say you want to find the standard deviation and the mean, right? So we'll start with the mean. So we want to find the average. Can call the mean function, we have that. Move around it, it gives you the description, it just gives it arithmetic mean. Right, it gives you the mean. Let me remove this, so it's gonna give me the same thing. It gives you the mean, right? And now let's try to do the standard deviation. So with the standard deviation, you just say SD. You can just find the standard deviation. With that, is everybody on par with that? I'm guessing everybody's fine. Okay. Let's look at this one when I try to find the mean of this data, of the same data. But now I'm looking at the row and not a column. It tells me a warning message. It returns an A. What do you think that is the case? Sends me a warning message. What do you think that might be the case?
I think it may be reading the heading.
Okay, let's try to do that for the column. The column is fine. Seems like it's not reading the column. But now with the rows, it's a problem. Let's not do the first one. Let's do probably the sixth one. It still gives me the same thing. Remember that this is just a row, one row. So it doesn't really read the headers. So what might be the problem? What do you think might be the problem? Doesn't give me an error, just gives me a warning message. That's all. So please also note that that doesn't give me an error. It gives me a warning message. The sum is that the argument is not numeric or logical. It returns NA. So as I told you that,
Maybe there is
Mm.
missing file values,
missing
values in the row.
missing values. Let's print the values and see. So that. So this is what we have, and just to make sure that the dimension is the same. So the dimension of that is 1:40. So we know that doesn't miss anything in every value. You see? So there are 40 columns and they all have entries. So we know it doesn't read the headers and we know there are no missing values, but it still tells us that there's a warning message and it still can return the mean that we want. I mean, we can see that there are values here, but it still struggles to give us the mean of that value.
Maybe the class, one of them, the class is different. It's not numeric.
Okay, we can also check that. Data frame, right? So because we have different columns in the same row, so that would be a data frame, that's fine. So the reason why it does this is because it reads it as a vector. Instead of an array, it reads it as a vector. So it converts this object into a numeric vector. So it is a number, but it converts to a numeric vector. So there is a way to actually solve it. So with columns in general, with rows, it reads it as a numeric vector, but with columns, we didn't see that problem. So with columns, it was fine. So there is a way to get around this. So we actually. So because we know that this one gives an error. There is a way around it to tell it to, instead of seeing that as a vector, just see it as a number, right? So we just need to convert that. So you're telling it, okay, still, you still need to find the mean, right? But see this as numbers and not as a vector. So I'm gonna introduce this function as dot numeric. So you're telling it to look at it as a numeric number and not a vector. So you can either continue typing, or if you're not sure which one you're actually supposed to use, you can just scroll down, right? And then n should be somewhere here. And then we want to set as a numeric. And then we include this whole thing. So now it gives us the mean. Now it's fine. So the problem here, the reason why it was giving us an error was seeing this row as a vector, right? A numeric vector. And so it couldn't perform the mean operation on it because it sees it as a vector and doesn't see it like just a small part of a number. So when we say, see this row as just numeric, not vectorized, just numeric, then it can determine the mean.
But why this happened only with the rows, not with column?
That's how actually RStudio root says it. I'm not sure if it's an inbuilt thing, but that's how it sees it. It sees it as a vector instead of, and that doesn't actually happen with the columns. So it only happens with the rows.
Interesting. Good. Thank you.
Yeah. So I think probably it's an inbuilt thing. Probably just automatically converts that to a vector. So yeah, we have standard deviation, we have the mean, we have the we did the maximum, the minimum. We can also do, what else can we do? I think we can also do the median. So these are the common statistics that most people use when they do data analysis. You can also do the median, so you can do a whole lot of this. So now suppose that you don't want to be busy typing this, like type the mean, the median, like as we did now, like type the median, standard deviation, and all of those things. You want to get them at just using one line at a go, right? Just to save time. You don't want to always like be typing the whole thing, right? So there's a function that actually invokes everything that I've just did now for statistics, where you can get the summary of all the statistics that you want for your data. So it's basically called summary, right? It tells you is a function that produces result and summarizes those results. So right, so we have this, and let's say you want the summary of this data. But let's continue with this one. It's fine. And then we run it. So it gives a whole bunch of stuff. So remember now we only specified the row and then we didn't specify the column. So it's gonna find the minimum, first quartile, the median, the mean, third quartile, and the maximum for all the other 40 columns for this row. Right? I mean, if you just want for just one, let's say for a certain column range, then you can also do that. Let's say 1 to 5. It just gives you that for 1 to 5. So the minimum, first quartile, third quartile, mean, median, and max. Right? And doesn't give you the standard deviation, so you're gonna have to do that on the side, but it just gives you at least this one. So you don't have to go doing this over and over again multiple times. So just this is the summary that it gives you for the data. So I'm guessing everybody's on par with this, right? And now there's another way that we can actually do everything that we did with just one line using the apply function. So again, this is the apply function, right? So what it tells you is that you put your X and the margin. I'll talk about the margin as we go on, and every other arguments that you want to put in. So it gives you a vector or an array or a list of values by applying a function to margins of an array of matrix. So here we have margins, and when we have the margin is equals to, so we only have two margins, 1 and 2. So it can be 1, the margin can be 1, or it can be 2, right? So when they say that your margin is 1, it means that you're looking all over your rows. And when they say your margin is 2, it means you're looking at the row, at the columns. So margin is equal to 1, you're looking over the rows. Margin is equal to 2, you're looking all over the columns, right? So let's apply the apply function. So let's say apply. So we need our X, and we need to tell it where it should look. Should it look over the columns or it should look over the rows, right? So let's say we want it to look over the rows. So our X will be our data. So our data is that, right? You can specify, we'll make more specifications as we go along. For now, let's look at just the whole data. And then to separate our arguments, we use a comma, right? So in this case, we don't use the quotation marks. And we're telling it to look over the rows, right? And we're telling it to find the mean. So this is what it does. So it looks over the whole data. However, it's only interested in the rows, and it's gonna find the mean for all the rows in the data. If you want for columns, you just remove the 1 with the 2, and it finds the mean for all the columns, right? Or you can explicitly write it down as margin is equal to in case you might think that just writing a 2 might confuse you. So 1 is for rows, and then 2 is for columns. So you can explicitly write it down like this. And then you press enter. Then if you don't want the mean, let's say you want the median, you can do that and then find the median over the whole columns. So this is actually cool because now it saves you time instead of having to write all of this down like that. You can actually have this and then apply it all over your data. So it's not limiting you to just applying to a certain column, a certain row, or apply all over your data. But the limitation is that you have to select that whether you want the statistic measure to be over the rows or over the columns. So that is the only limitation, but it still saves you a bit of time. So now let's look more into detail into our data. So let's say we have this. Let's say we have the same thing and then we want this the average. So instead of having to type this all over again, let's say we put a variable to it. So average day inflation is given by this, right? So for now, we'll just look at the mean, and that is what we're going to be using to make our plots. You see, it doesn't print out anything because this is just a variable and the value. So in order for me to see what is this, I need to print this. And then I run it, and then this is what it returns, right? So this is just the mean for all the rows represented by the certain number of days, right? So already introduced margins, so that is fine. So we'll try to plot that, right? And yeah, we'll try to plot that using different plotting types and try to introduce on how you can actually parameterize how do you say it? Introduce more parameters into your process, like how to print it, the labels and everything, right? So sure. So for now, I want to introduce another thing where you are subsetting your data, and I'll explain that more as we continue. So let's say you have this, you can call it anything that you want, right? So you have this thing called animal, and you want to have this entries. So you can call it any entries that you want. And remember, since we are dealing with a string, so whenever you're dealing with a string, you need the quotation marks. So you have could be anything that you want, can be 4 words, it's fine. And then you have n, I'll probably make 4 entries or 5. And then we have O. And this is going to be essential subletting data, as we see when we're going to go back to the actual data that we're dealing with. And then we have K. Doesn't have to be a specific order, you can just write anything that you want. And then you try to Z. Yeah. So this is fine. So I just defined or sublet this data. So I just defined this. And if you print it, this is what it looks like. By just strings like that. So I haven't really done much onto it, right? So let's say now I want to print the last 3 columns of the first 2 columns. We can do it the way that I showed you using the range part, right? So you can say animal, and you want to print the last 3 or any range that you want. Let's say the last 2. And correct them in 2, 4, 5. Oh, I see the problem. This doesn't have rows, right? So here it prints the last three. So my question is, how can you print this in reverse order? Like the same lines, the OKZ in reverse order. So instead of OKZ, you have Z KO. How can you write this in reverse order? Do you have any idea how you can write this in reverse order? Any pointers?
I'm not sure, but
Mhm.
maybe there is something called reverse or RE.
Pardon?
Maybe there is, you can add something called reverse on to the code.
Okay, I understand. And yeah, unfortunately, we don't have that. So the only thing that you can do anymore is just to do this. So reverse the order that you actually call it. So because now you started from entry number 3 to entry number 5. So now you're telling it start from entry number 5 to entry number 3. So this is how you can reverse it. Sometimes this is essential in data analysis, and we'll see as we continue. Right? So you can do that. So now, what does this command do? When you run it on your side, what does this command do? Number 51. What does it do? See, if I just remove the negative, I get M, but if I put a negative, what does it do?
I think it will show error.
So the negative explicitly means it removes the first entry. So it doesn't really necessarily show an error. It removes that entry. Right? So another thing, if you have this data and you don't want to, there's certain data parts that you actually don't want, you can just remove them, right? So let's say I want to remove entry number 4, I just say -4. So I can remove that, I can only deal with what I actually am looking for. Especially like when you're dealing with an array or a matrix. You can just do that simply and just deal with what you actually want to look at. So if animal -4 removes the 4th entry, what does this one do? Okay, let me write on the same thing. What does the new command do? Number 52.
Delete the first 4.
And you are right, it removes the first one and
From the first one to the 4th.
yes, it removes the first one to the 4th. So remember this range. So it removes the first one all the way to the 4th one. So I'm only left with this one. Right? So that is what it does. It removes the indexed element. Right? So we haven't used this one that much, but I did introduce it a bit. So if I have this, or let me just probably write it on line number 50. So if I have a C there, what does this do? Like I introduced the C in the 2 brackets. What does the line 50 gonna give me? The new command that I've written, what is it gonna give me? Any takers?
Reverse order from 5 to 3.
Reverse order, same thing. So this doesn't really change what the first command actually had before I put this. So it doesn't really change it, right? So now let's say I do this then. What does this new command do? Still number 50. When I say 124, what does this new command do? Remember, it can be arranged since I don't have the column. What does this new command do? So when you type it out in your RStudio, what does it give you?
M, N, and K.
Pardon?
M, N, and K.
Yes, M, N, and K. So it gives us the first one, the second one, and the fourth one. Right? So remember, with the C command, you can actually specify which one that you want. So instead of this, let's see if I don't have the C, will I get the same thing? You see, it says incorrect number of dimensions when I don't put the C there. Let's see if I just include the brackets without the C again, it's going to give me the same thing. Again, it also complains. So this C actually tells you that you can just look at the specific elements that you want without getting an error. Because without the C, you can't do that. So that this is important for that. You're just choosing your own. You have the freedom to choose your own. Right. So this is what we have so far. So I'm gonna go back to the data, original data, where we are gonna subset it and reassign it. All right, and I think probably we can do that after the break. Let's do 10 minutes and then we'll get back at 11:15. Any questions before we go? Okay, great. I'll see you at 11:15. Continue now. Thank you. Let me share my screen again. Let me put the chats on this side so that I can see. So I'll just keep on looking at the chats on the side so that I can see when people respond. So now we're going back to subletting and reassigning. Okay, I did share my screen. So now suppose you want to look at the patients, right? However, now you want to look at for every 2 days, all until day 14, right? Or you don't even have to do it for the days. You can even do it for the patients. Let's say the instrument that we're actually determining the inflation for all the 40 days was actually making double of the whole thing, like was doubling the, what do you say, was making double of the data for each patient, right? So instead of just making one entry for the patient, it was making a duplicate, right? So now we are trying to remove that. So basically, you're gonna try to study the data for each and every patient, but so that you actually have 60 data points instead of we have 30 data points instead of 16. So what I'm trying to say is that so we have this data, right? So now, instead of, we're trying to start from patient number 2 all the way to patient number 16 and skipping the second entry, right? Because for some reason, the machine recorded the entries like twice, right? So a way to do this, remember when we ran something like this at the top, it gave us an error. So the way to do this is to define a function or use the inbuilt function that is already in RStudio. So that is called sequence. So if you hover around it, so it generates regular sequences. So we want to eliminate some of them repeated data points, right? So we do this. So the same entry that we had here, just put it here. So Control X, and then you put it there. Right. So what this will do is that starting from entry number 2 to number 6 is going to remove the second entry, right? So that we don't have any duplicates in our data, but we don't need this. And I'll explain further as I continue, right? For all the patients. So let's provide this with a variable. Let's say which patient. You can name it anything that you want, right? So you're telling it that move from number 2 to all the way to patient number 60, and then for the second entry, just remove it because it's just the duplicate of what we already have. But this doesn't read from the data that we already have because there's no data at any point. So this is just a variable that we are introducing, and we're going to invoke that on how to read the data that we actually want. So you can just do it for the whole rows or just for a certain number of rows, depending on how your data looks like. But for this case, let's say we want to remove every second entry because it's a duplicate. Yes. So now what we'll do is introduce another variable, which we're just gonna say that you can name it whatever you want. And we wanted to read whatever our data, our original data has, right? So we are getting this new variable and we wanted to read whatever our original data has, right? And we're gonna try to include this new command that we have there, right? And the way to actually do that is saying, take this data, which is gonna read whatever is in here. So it's gonna, that too, it's gonna read whatever is in here. And now it's gonna include the command, the new command that we've introduced, that it should skip every second entry of the patient. So this was going to be on our row. We haven't really done anything with the columns, so we'll just leave that for now. And then you should run it, and this is what you get. Right? So they've omitted 5 rows, so we have more than 50 rows, right? So from theory, what you expect to have 30 rows, because we are saying skip every second entry because that is just a duplicate of the data. But what we're seeing here is not 50. Let's determine the dimension of this to see how many rows specifically do we have. And then we're just going to take the whole of that and then put it in here. So you have 30 and 40. So it means we are on the right track, right? I mean, you might get confused with this portion, but it means that we are on the right track because it is 30 rows and 40 columns. So it skipped the second entry each time, right? And now if you want to specify probably the days, you don't want for the whole 40 days, you can also do the same thing using the sequence command. So let's say this is just days, which day, and you want to look from day 1 to day 5. You don't want it to skip any days. You want to look from day 1 to day 5, and then you can have this in here. And if we run everything, so these are the dimensions, right? So it tells you that we have 30 rows because we skipped the second entry each time, and then we have 5 rows because the sequence that we have is that we're starting from column number 1 to column number 5. We have 5 columns and 30 rows. So now you can just specify which part or like how the sequence you want the data to be. If you wanted to skip, let's say, every third entry, you can do that. So I have to run the whole thing again. If you wanted to skip every third entry, you just put 3. So for those who already know Python, you'll have the first entry, second entry, and this will be like the steps. So here we're skipping the third entry each time, and then repeat the same thing. Skip the third entry each time and repeat the third thing. And if you look at the dimensions here again, it's no longer 60, it's no longer 30, it's 20. Because we are removing the third entry each time. So it's even reduced. So you can change this however you like, depending on how your data looks like and depending on what you actually want to do with the data, right? So what I want you to do now is to write a command in your RStudio to calculate the mean inflammation for patients for these days, for 1 to 5 days, over whole 40 days. So here I didn't put anything, so it's just going to be over 40 days. So determine the mean inflation in your RStudio for this command, and what do you get? So just use what we've already established before the break. So trying to find the mean inflation for this. And what do you get for that when you do it in your own code? Please write in the chat if you don't want to unmute your mic and say it out loud. If you're also confused, please let me know.
Hi, DJ.
Hi.
Hi. I'm trying to compute the mean, but I'm getting the warning message that my argument is not numeric. Could you please help me?
Okay. Use the numeric function, the numeric command, so that it reads it as a numeric instead of a vector. So remember the numeric one was somewhere at the top, this one, on line 34. Anyone else having trouble with that? Do you guys have any problems so far? You are still trying to type it out? And please let me know if you have any problems executing that. Or instead of using the new data that we just defined now, because it's going to be a long command, just use the original one, just that, the old variable that. And find the mean in this range. So for these days. Any takers? Are you guys okay? We're having a bit of trouble still continuing with it. Until 25. Wait, what do you mean until 125? You get everything until 125?
So if you were to run your data, or that section of your data from 58 to 63, when I say data, I actually mean your commands, sorry.
Yes, 58 until 63, yes.
The last output in the console is 20 and 5.
Oh, okay.
Am I
Oh, I
correct?
thought you were getting an error, okay. And then what about after which I cannot command the main? What do you mean by that?
If you could do me a favor and run 58 through 63.
Okay, let me remove this one because that is the same style. Okay, run this.
So after I receive these two numbers, in my
Yes.
case 20 and 5, I cannot compute a mean on the dim.
Oh no, you're not. Remember that this dim is just it shows you the dimension of this. So the mean
Right.
shouldn't even include the dim. Yes, this is just show you the dimension.
So we should have mean left bracket as dot numeric, another left bracket, and perhaps date 2, DAT2.
Wait, you said, let me write it down. You said, please say that again.
Mean
Okay, mean.
left bracket as dot numeric,
Yes, numeric.
left bracket, DAT 2, number 2.
JT2, yes.
Yes. And I get an error when I try to run that.
Oh, yeah. So now what we're trying to do is try to determine the mean. It's confused. You're trying to determine the mean for rows or columns. So that it kind of can't comprehend that. So you have to like specify. So what are you trying to find the mean of? Because now it doesn't know whether you have to go across the columns or the rows or specific entries because it's the whole data set.
See. I
Yeah,
see.
yeah.
So I think depending on your question, I would try and specify the correct row or column using square brackets.
Yes, yes. Let's let me do it now. But thank you so much for that.
Thank you. And thank you for helping me.
Thanks. Okay. I mean, we can do this as numeric, but we want to find the mean. So here, we can just use the apply function. I mean, you can also use the standard mean function, but let's just use the apply. Right? And then our X would be the data. So it would be that. So let's see what that 2 looks like. So this is what that 2 looks like, and let's see its dimensions. Sometimes it's easier to visualize data when you know its dimensions. Because you know what it's supposed to look like. So it says 60/40. Why do you think it says 60/40? So there's that 2. Any takers? It says that the dimension is 60/40. So 60 rows and 40 columns. I do think it says that. because this is not what we want. But this is what it gives us. So we have a problem. Why do you think it says we have 60 rows and 60 columns and 40 columns, sorry? Any takers? So remember here when we defined that 2, we said it should read data from our original data, right? So what we actually need to print is this. So we are telling it that it should take this sequence. Remember I had a 2 here. Let's say that already makes less entries. Let me just stick to 2 there. For every second entry, remove it, right? So this will be the rows. It's gonna have less rows compared to the original data. So that 2 reads data from the original data. So if we don't do anything to that 2, basically it's the original data. But now we're trying to manipulate it a bit. So we take the original data and we want to remove every second entry, right? So that we have 30 rows instead of 60. And then we look at the columns. You don't want the whole 40 days. You don't want the information of the patient for the whole 40 days. We're only interested at least in the first 5 days to see what's happening, right? So this is what's happening. So this is what we're going to be putting here. So the whole of the step 2. You can also use a variable instead, in case this might be a bit too much to include in one line. You can just also include a variable where you assign this to a certain variable to make it a bit shorter. So remember, for apply, we have this, right? And invoke a name. Then let's say minus something else. So now this is fine. And remember that the dimension of this, the whole thing. So remember that that 2 was the same dimension as the original data. So the dimension of, I already have it there. Dimension of this was 59. Oh, I didn't run this. That is why it's 59 and 5. Yeah, now it's fine. So remember, yeah, you see now, because I changed this, but I didn't run it the second time, it was still reading the old command. So it's important to make sure that if you're gonna use a previous information, and when you've changed it, make sure that you always run it so that the new lines can actually still use the new information that I've provided for it. So the dimensions are fine. I have 30 rows as expected. So I have 30 columns, 30 patients, and I have 5 columns. So for the five days. So this is how it actually determine a mean using the apply function and makes it a bit easy. Are we all okay with that? So instead of having to write a long code, we can just determine the mean using a very simple line. So I'm hoping everybody is happy with that. And I'm hoping that you're also getting the same on your side as you're trying to run this. Right? So you can do it with all the other statistics. So you can see here that we extracted certain part of the data. We didn't deal with the whole data. We extracted certain part of the data and we're doing statistics on it, right? Without affecting the original data. So you can also do that without having an effect on the original data. We still have our original data, which is untouched, and we're just doing statistics on part of the original data. So you can do other things, mean, median, standard deviation, and all those other things. So for now, we'll just stick to the mean, right? So you can do the same thing with the original data if you specify the rows or columns that we actually want. So we are calling the original data that we already defined previously. But now let's specify, remember when we ran it without any specifications for the rows or columns, it get confused. So it doesn't know whether it's working for certain rows, certain columns, or certain part of the data. So we need to make the specification. So for now, let's say we are looking for all the rows for all the patients. We are looking at their progress for their first 10 days. So in order to make a range, which means for the first 10 days, that would be from 1 and then until 10, right? So now we are going to be looking over the columns, right? Because we are making a range for the columns. So we're going to be determining the mean over the columns instead of the rows. Right? I mean, you can do the same thing. So if I put the range over the rows, then this 2 will change into a 1. So depending whether you want your mean over the rows or over the columns, you can change the margin from 2:1. So let me just write it down as margin. Yeah. So now we want the mean over the columns. So we're gonna set our margin as this. So here we wanted it over the rows, and then we make the margin 1. So this is what we have so far, right? So this is the new data that was extracted from the original data, and this is the original data. Already seen something like this when we did the analysis in a few minutes ago, right? So now, let's say now when the average inflammation, so we did that, right? From skipping some of the patients because now the data was being reproduced, was being duplicated, yes, was duplicated, right? So there's a way that we can actually do what we did here in just one line. So instead of having to do everything like that in just one line, right? And I'll show that in a few minutes. Does everybody have any questions so far? Are your codes running on that side? Have any problems? Thumbs up if you're okay. I'm assuming everybody's okay then. So let's do this in one line. But so instead of having to do that and get the mean, let me remove this. So instead of having to define the patient, the days, this, and everything like that, we can do this in just one line, right? So again, we still use the apply function, right? And depending whether you want to use that too or that, just the original data. Let's say you want to use the original data, it's fine. Right, so I'm gonna go to the original data and then I'll make modifications to it as we go along. So it's original data, all the rows, and then we have this columns, right? But now I want to invoke the sequence. Can you please, if you can send me so we have this, just need to modify it, right? So try to use this and that in the new line and please send it in the chats. So how do you think the new line is gonna be? So I want to do the very same thing that we did here, but in one line, isn't this? How do you think it's gonna look like? So let me remove the entries. So the main thing will lie what it's in here. So everything that's in here, I want to do it in one line. How do you think it's gonna look like? So try to send some whatever that you have in the chat, and then we'll work through it together. So what's the important part is what it's in the square brackets here. So I'll just give you 3 minutes and then at 11:45 we'll continue. Even if it gives you an error, just send it on the chat and then we'll work it out together. or you can just share your screen by the time it gets to 11:45. Okay, I see you have apply. Okay, then which point? Okay, which day? Okay, I understand what you did there, right? But we want everything that's in share to be in one line, including the which patient and the which day to be in one line. So the which point and the which day should also be in this line, but I do understand what you did. So 2 minutes to go for people to think, get out. And they should be there too, yeah. Any other takers, a minute left before we continue? So everything from 58 to 63 should be in one line. Except for the dimensions, you don't need the dimensions. Just need the which patient, the day, this, and determining the mean should be in one line. Okay. So essentially what you're gonna be doing here, right? So you don't have to set the variable. So for this part, you don't need to set the variable, right? So here we needed the variable because we can like call it into the function that we're using. So now you don't need to set the variable, right? So remember now, using the dead2, which is the original data, but now we need this sequence for every other patient. The data should be removed, right? Because it's a duplicate, right? So we are gonna need this, of course, because we need the rows and the columns, right? And the margin is fine over the columns, and we also have the mean, right? So now we need this sequence. So basically just copy this. And you have that there, right? The difference now is that instead of the 2 being there with the sequence inside, you have to specify it by this, by. So you have to like call it out instead of just writing a 2. And this should be, give you the mean. Oh, I'm supposed to put it on this side, on the rows side. Yes, yeah, my mistake was I put it on the column, I should put it on the row. So does everybody like see how we did this? So just in one line, right? So remember we're trying to find the mean. I mean, I can also include the days. So the day is from 1 to 5. So let's do that from 1 to 5. Yeah. So everything that we did from line 58 all the way to 63 is in one line in line 66. So I'm using the apply function, right? The one that I introduced before. And I'm telling to apply whatever that I want to this data, right? So without any other arguments for this data, this is just the original data. But now I'm telling it to do some stuff with it. Oh, yes. So we have the columns, the rows here, And then we have the columns onto the side. So the columns are fine. We're starting from 1 to 5. So which day from 1 to 5, right? Which was the sequence that we defined initially. Then now coming to the rows. So what we are again trying to tell it is calculate the mean inflammation for every second day or for across for all patients for every second patient, right? Because now we have a duplicate of the results, and that is not what we want, because now it's going to affect our results, right? So determine the mean from these days 1 to 5 for every second entry of the patient data. And then this is the mean that you get. 5 columns, and then that is what we have. But thank you so much, guys, for sending this. Right. So the apply function actually helps you to reduce a whole lot of steps when you're busy with your analysis. It makes it much easier. And what makes it also much easier is when like you put comments on it, like, what does this code do? It does this, it does this and that. Also has to write comments next to your code so that you remember even in future what this actually does. So that is how we can apply the apply function, everything that you want. Right, so instead of having all these lines, you can just write everything that we had there already in just a single line. Any questions so far? Or comments? This is like everybody's good. It's fine. Then I'll go to the plotting part, which is what we're supposed to be doing after the next break, but we'll start with it now. Right? And we all know that plotting is a great way to actually visualize our data, right? I mean, if we have all these numbers like this, it's hard to see how they are distributed, right? And the pattern that we might get from it, we can't even see that. So it's always good to visualize the data that we have. And one way is by plotting. So you can actually make various plots in RS in any other code. So you can line plot, scatter plot, and everything. So for now, let's try to plot probably, yeah, let's try to plot this. The average mean day inflammation. So just say plot. So you don't have to import any packages. Any packages that are needed are already in here. So if you hover over plot, tells you can plot your X or Y, then you can include extra arguments, right? And you will see what those extra arguments might be. So this is what we're trying to plot. Let me go back. We're trying to plot the average day inflammation. Then if you see on my bottom right, there's a plot. Is it visible enough on your side?
Yeah, it's clear.
Okay, great. Yeah. So this is the plot that we have, right? So I'm just putting the average information over the days. And automatically what it does for me, it puts, excuse me, whatever that I have as my x-axis and y-axis. So this is just, it puts this as the index over the 60 days. And since I'm plotting the average day information, it automatically puts that. But sometimes what you want is you actually want to customize your own titles and everything, customize the image as a whole, essentially. And we'll see how we can actually do that in a few minutes. So we have this plot. And another thing, let me try to do this, and I'll try so that you can see. Let me run this again. Yeah. So So I'm still running the same line, but gives me error in the plot, right? And it'll also tell you what the error is. It tells me that the figure margins are too large and there are other warning messages. So if you get this, do not be alarmed, right? The reason why it's giving me this error is that the image doesn't really fit where I placed it. So I need to make this a bit bigger so that the image can fit on the plots. So now I've increased the space for the image to fit. If I run that line again, then that error doesn't show anymore, right? So do not be alarmed if you like decrease the plotting space and then this gives you an error. It just means that you just need to increase the plotting area because now the margins can't really fit to make a plot. So that's fine. So this is just a scatter plot. So sometimes you might want line plot, a bar plot, or anything else, depending on what you're trying to do and what you're trying to achieve, right? So let's say for now we're still dealing with the scatter plot. But now instead of having these circles, I want this to actually have a different shape, right? So you can do that. So this the more arguments that you can include. So just type CEX, right? And is equals to, and also you can also increase the size and also the color. But this increases the size of this. So let's say the size was just fine, but now you want to change the shape. Let's remove this. And now you just want to remove this to change the shape. So since this is not a function, it doesn't really give you, because this is something different, it doesn't really give you the option for this. So the one that we just showed now was just another square parameter, a square parameter. So we are gonna say PCH. So the P is for the point, and then CH is for the shape. You know why CH, but that's the one. And this, instead of using symbols to specify the shape, you're gonna use numbers, right? Because I know in Python you can actually use symbols to determine the shape of whatever point that you're trying to look at. So now you have to use numbers. And they range from 0 until 25. So depending on which number. So let's try 0. So if I say 0 for the point shape, I get this little squares. And if I say 5, let's see, I get this little diamonds. So let's just go to number 25 and see what happens. Then I get this inverted triangles. So yeah, but there's documentation that you can look up for which number corresponds to which shape. So from 0 until 25, the numbers are assigned different shapes. So depending on the shape that you want, right? So now let's suppose that you actually do not want a scatter plot, but probably you want a line graph, right? So you can also indicate that by saying type, right? And then equal. And in order to make a line plot, L, and it tells me that object L is not found. Why do you think I get this error message? So L is for line, and now I want to make a line plot, but it tells me that this object is not found. Why do you think that's the case? Do you have any idea why do you think that might be the case? But this is string. So string needs to be in quotation marks.
This meeting is being recorded.
Isabel, are you saying something?
Sorry, I just muted them, but if there
Okay,
was a
thanks.
question, maybe they can unmute again.
Okay, thanks. Yeah. So since L is a string, you're gonna have to use quotation marks, right? So before this, when we go back so that you can see, we had this, right, as a scatter plot. So now if we want to introduce a line graph, we just specify the type. And then the L means that it's a line graph, and then we have this. And there are also ways where you can actually make it to be a smooth line graph, or make it a bar graph or something like this. So for now, for the purpose of this, I'll just stick to just making a line graph, right? Let's suppose we want to make it a bit thicker or a bit thinner, the line width. You can specify that using this line width and put any number that you want and see how it changes. So if I say 2, comes a bit bolder, right? And if you want it to be even more bolder, then you can just keep on increasing the numbers, right? And let's suppose now, let's take to the standard one. Let's suppose you want to change the color. You don't want it to be black, you want it to be a specific color. You can also make a command for that. So color. And then let's say we want to make it red.
Is it lunchtime, my stomach?
Right. Again, this red is a string, so it means should include this. So remember, for a string, do not forget the quotation marks, and then when you run it, it will give you a plot in red. Right? Yeah. Let's take a break here, and then we'll continue with making plots after 15 minutes. So we'll come back at 12:15. Any questions before that? Okay, so I'll see you in 15 minutes then. Okay. Let me share my screen again. Let's mention. Nice. Anything in the chat? It's on. Yes, so let's continue to making plots, right? So as I've said, we can actually customize this, make our own labels and make our own title instead of using the ones that R is already reading from our data, right? So for that, down the same line, let me remove this. So in order to actually make your title, you're going to type main, right? So this is the main title for the plot, right? And then you can call it whatever. So let's say my plot. So that would be your title. And then if you want to do the X label and the Y label, you say X label. Then you just give it a name, let's say days, right? And then if you want to do the Y label, do the same thing. Average information. Implementation. And don't forget this is string. So you're gonna need this quotation marks. Yeah, so you see, I made actually double, so it actually also highlights this part as green, and this is, I don't want this to be in green, I want it to be pink. And then my plot. Then when you run that, you get your own customized labels for your plot, right? So now let's suppose, so in a new line, don't forget to save your work. So in a new line, you want to determine the maximum inflammation for all the patients over all the columns, right? So we are again gonna introduce a variable like we did here, like we did with the average day inflation. We're also gonna introduce a variable. So now what we want is the maximum inflation for all the patients over all columns. So let me write that down. So for comments, you use hash. So maximum in inflation for all columns, for all patients over all columns. All columns. So this would be my max. I mean, you can write this as anything that you want, right? So I want to find the maximum inflation for all the patients over all the columns, right? So over all the columns will determine the margin that I'm using. So in this case, I'm gonna use margin is equals to 2. So for this, I can use the apply function, which makes it to in just one line. Oh, it's not equal, it's this. So I can just use the apply function. So given what I want, what do you think is going to be inside the apply function? So you can just write what you think it's going to be including the apply function in the chat. So remember, I'm just looking for the maximum inflation for all the patients over all the columns. So what do you think should be inside the apply function? So try it on your own, and then if you have something, just include it in the chat. I'll give you 2 minutes, and then we can do it all together at 12:23. The maximum inflation for all patients over all columns. If you're also confused so far about what you're supposed to do, you can also let me know. Okay, say apply max that to from over all the rows 1 to, I'm assuming you wanted to say 1 to 60. Third. Okay, great. Yeah, so from 1 to 60. Anyone else? So remember yet that with the apply function, whatever operation that you want to do has to be at the end, so it doesn't have to include the actual data, right? So remember when we applied when we used the apply function, I don't have to use the whole apply thing multiple times. When we use the apply function, let's say here, okay, this one is a long thing. Let's say which one is a bit shorter. This one, I'll just use that one then. So apply, you have the data and whether you want it to do over the columns or the rows and the statistic that you want to use, right? So this also has to be part of the argument, so it's not going to include the data. So the data on its own and the statistic function that you want to use on its own. There's not supposed to be with the data. So it's separate arguments, but thank you for that, Ziad. Yeah. So now we want the maximum inflation for all the patients over all columns, right? So we're gonna look at the same original data because it's for all patients. So that's why we're using the original data instead of the new data, which is that too. So the original data, right? And we'll make specifications on the data later on. And we know that what we want the maximum, right? So this is the function that we want, the values for that. So we want the maximum inflation for all the patients. And since we are looking at over all the columns, means that our margin should be 2. Right? And then for the data part, we don't make any specifications because we want for all the patients over all columns. Right? So what this command does, it looks at your data, then looks at the separate columns and determine the maximum for each and every column. Right? And remember when we did, I'm not sure where, but we wanted to find the mean or something for the data. It becomes hard for us to actually determine which order you want it to be in, because you're not specifying whether you want it to be across the rows or over the columns. So now we're making the specification that we want it over the columns. So we run that, and then the input that we get, the output that we get is nothing. The reason why is because we're making a variable. So this is the variable, this is the input. So in order to print what this actually is, we have to operate in a command on its own. So this is what it gives us. So this is the maximum value for all the inpatients across all columns, so across all different days. So this is the maximum that we get, right? So the apply function actually makes it easy to do this in a simple line compared to having all these different lines. So the apply function actually makes the whole thing actually look neat and readable. Because one of the problems is that you might have this complicated code with a whole lot of stuff and makes it even difficult to actually read it, right? So now we have the maximum inflammation for all the patients. Let's visualize that. Let's see how that looks. So introducing the plot function and now trying to plot that. So this is how it looks like. Right? So it's telling us that with the maximum day inflation and inflammation, it increases for the first 20 days and then decreases for the rest of the days. Right? I mean, if you want to make this to be a line, you can also use that by typing type and then make it into a line, and then you can do other customizations if we've already looked at. So this is what we plotted so far. So let's say sometimes you just want to actually make multiple plots in one plot. Let's say you want to show multiple cows in one plot. You can also do that, right? So let's say here the one that we've dealt with already. Or you just want to change the type of the plot. Let's say one bar plot. You can also get bar plot, right? So you have that. So if now you want to make multiple girls in one plot, let's say the first one, the type, you wanted it to be a line. So we're not gonna run this command. I can comment that since I don't want the bar plot, that's just for illustration purposes. I can comment that so Studio won't be able to read it. So if I say line instead of plot, but still with the same, now I'm saying line instead of plot, and we'll see what happens. Well, I should be plotting different things because now I'm plotting the same thing. For the line, let's include this one instead. The average day inflammation so that you can see the differences. So I'm plotting the max day inflammation, the maximum, which is a line, and I'm plotting the average day inflammation. It's showing the same thing, but it's fine. It's actually plotting the same thing for the mixed day inflammation and the average day inflammation. So do you think what I've plotted here is correct? Given the data that we have. Look at the plot and also look at the data that we have. Do you think what I have here is correct? Any takers? So I'm plotting the mixed day information and the average day information, but I'm still getting the same thing. So one of the things that we can do is to determine what the function does, right? So I have line there, revised line fitting, and I also have line. So it means that the ones that I was using was actually wrong. This is the one that I'm supposed to be using. So instead of lines, I was using line. Again, you can just type the function that you want and then hover over it to see this description. So I was using this one instead of that one. So this is for graphics, the lines one, and I was using the line one. So that is why I was just not getting the plot that I actually wanted. So this now is fine. The plot that I now have is fine because I'm plotting the mixed day inflammation represented by the dots. And I'm plotting the average day inflammation, which is what we plotted here before. So this is fine. So this would be you trying to make two different plots in one figure, right? You're just using this line command and then you get the line plot that you want. Any questions so far? It's fine. So now, let's say now instead of having to define a variable like I did here and then assigning it a value, we are trying to minimize the code again. Can you do the same thing, right? But let's exclude this one. I'm going to comment that one. So for these 3 lines, can you make the plot using only one line? So what would be the command for that? So trying to plot this, the 3 lines that I've highlighted using only one line. Let me give you like 3 minutes. Then at 35 we'll resume. So if you have a command for that, please type it in the chat. You can just show your screen for that. So the 3 lines that I've highlighted, I want them to be in one line. How can you do that? We'll try to see if we can figure that one out. And if you have any trouble, just let me know. And in 2 minutes, we'll try to look at that together. Now you're trying to avoid having to set the variables and everything. We're trying to avoid the variables and set everything. You just want to plot this in one line. How can you go about doing that? Any takers? Any idea of how you can do that? Similar to what we've already done in line 64. When we avoided to use the variables and just used everything in just one line using the apply function. So we use a similar thing even here. Any takers so far? We'll try to make a plot on your side and see if you can make it in one line. So all of these 3 lines, you can reduce them into one using the apply function. I'm using the wrong apply function. Right. So now what we want to plot this, right? The mixed inflammation. So let me just only run it. We want to plot this, but we want it to be only in just one line, right? So it's still gonna be do the apply function and then include everything that we want, right? We have the data, want it over the column, and then want to determine the maximum. You can also do the mean. It's why it doesn't matter whether you do the minimum or the maximum of the day of the inflammation of the patients. Let's just stick to the maximum. This is what we have, but we also want to plot it. So this is a plot function, and whatever that you have here, you just put it in there. Then find plot apply, or should be brackets. But apply and need another bracket. Yeah. This is fine. Yeah. See that cross, that cross there is now removed because now my brackets are fine. So you see, it still does the same thing. I'm still plotting the same thing. And now what R is also doing is that it's reading whatever my inputs are and putting them as my labels. But we already established how you can change the X label and the Y label using this in your as part of your arguments. And so you can also change the labels. So let's include the plot, the title, the X label, and the Y label. It's just my plot, then it's the days, and then mix inflammation. and then it changes. So now I did the same thing, but now in one line in a more neat way. So instead of having all these variables, these multiple variables, and plotting it, I just use the apply function and the plot function in one line, right? So you can also do the same thing with the others, with the minimum, the maximum, and the standard deviation. Are there any questions so far, comments? Please give me a thumbs up if you're able to do this on your RStudio editor. And did you guys have trouble able to do this? Thumbs up if you're able to do it. Okay, I'm hoping that you're actually not having trouble on that side. I had to spend some time tutoring the first test. Okay, thanks, Sid. Thanks. Okay, that's fine. And you can also find the recording, so it's not a train smash. You can also find the recording. Yeah. So let's try a similar thing using the standard deviation, right? So on your own, try to create a plot that shows the standard deviation of the inflammation for each day across all patients. In one line again, standard deviation for the information for all patients or across all patients. They shouldn't really change that much from this one, right? Because now if you're looking at standard deviation, it means instead of max, we're gonna put SD. And if you're not sure that this is really the standard deviation, just anyone on empty space type SD. They should be able to show you the functions. I'm not sure why it's not showing standard deviation, but it's supposed to show. But this is the
I
standard
think maybe
deviation.
it's just STD maybe?
Let me check. Oh, this yeah, this is something different. Yeah, I think
Okay,
probably
sorry,
doesn't
it was
show
just a
because
guess.
yeah, I think this doesn't show because it's just 2 letters, but this is the one for standard deviation. So basically, you can just do the same thing, and you can play around with this using the different statistics, right? And probably just want to look across the rows. So for all the days instead of, so you see that if it's across the rows for all the patients in different days, then this becomes a bit more scattered. So you can actually play around with this. And one of the things that I know are mostly very important in data analysis is having to fit your data, right? So, I mean, this one would be a bit more hard to fit because everything is like almost scattered. But if it's across the columns, then it looks much better. So you can try to fit this, something like this, and from there you can try to find the chi-squared or any other statistic correlation or something like that you want, depending on what you want. And that's also part of like the homework. You can do it at your own time. You don't have to do it. It's just for you to try to see if you actually understand what we've done so far. Let me show it on this side. Yeah. So I know in my field, I'm not sure in other fields, but scatter plots are very essential, and having to be able to fit the data is very essential. So if you have a scatter plot like this, then we can include statistical parameters, which actually tell us a lot about the data that we have and how it deviates from the standard or from the mean, right? And sometimes we add the line of best fit and we determine the reduced chi-squared. So in your respective course, because I see that most of you are like I'm from the industry, you can try to make a similar thing despite the data type that you have. So it can be CSV, text, .dat, .ascii or anything. So mostly I use almost every data type here. So you can try to do something similar to your own data type. And yeah, if you have any problems with it, you can email me. I have my email address up here. Am I here? Yeah, I have my email address here because I've dealt with all of these data types so far. And I've fitted most of them and everything like that. So just to get a heads up of like how everybody's using data in their own respective fields, have you guys used any like multiple data types from here, like CSV or text or that or .sk or anything that I've been mentioned here? Type in the chat if you feel comfortable doing so. So the data that we mostly deal with, which format is it in? Anyone? CSV and text are most used at this moment. Yeah, I also use a lot of text. Yeah, so there's the data. I also delete a whole lot of data. So having to be able to analyze them within a new programming code actually makes it more easy to do that. Because I also deal with a lot of models for that. Sometimes Amy uses Excel. Yeah, it's best to convert to CSV. I also find it that it's best to actually convert to CSV. So yeah. Yeah, so try to do this. You don't have to do it. I mean, if this is what you usually do on a regular basis, then you're already familiar with it. But for those that are new to it, you can try to do this. And if you have any hassles along the way, just email me. So far we are done for this portion. So for the next day, for tomorrow, we'll be looking at so for tomorrow, we'll be looking at functions, how to define functions and how to use functions, how to call them, right? And also using loops because you don't want to be doing the same thing over and over again, right? For different data types. And we'll see because we're gonna use a lot of those data that we've used so far because now we only just looked at one information 01.csv. So we're gonna try to use all the different the data files that we have already in the for loops so that you don't have to do one thing over and over again. So this part is going to be the essential part for loops in data analysis and also introducing functions. So are there any questions? So I think we're gonna end up with like 10 minutes earlier than expected. Any questions or comments before?
I have a
we end
question.
them? Yes.
First, thank you so much. Thank you very much for the
Pleasure.
presentation today.
My
I
pleasure.
learned so many new intricacies about R that I didn't know before.
Mhm.
Thank you very much.
Pleasure.
And my next question is, could we please paste the links to each day's presentation in the first Cody file?
Oh, I think Tutugulas said they're gonna be made available. You mean the recordings, right?
Yes.
Yes, I think Tutugulas said they're gonna be available after the whole workshop. Am I right, Amy?
Yeah, I haven't actually checked. I'll check quickly if there are any recordings already on the NETEX YouTube channel, and I'll just share the link to the NETEX YouTube channel as well. I'm not sure if they're there yet. I think that they aren't yet, but I'll just confirm that now.
Okay, yeah.
Okay, so it sounds like the plan is to post all these recordings to the NETEX YouTube channel and for all of us to access it on YouTube.
Yeah, I
Like
think
that,
that's
yeah.
the usual thing that happens with all the NETEX events. Yeah.
Okay, thank you very much.
Okay, thank you. Any other questions or comments before we end the session? Looks like everybody's on par. So thank you so much, guys. I'll see you tomorrow.
Sorry, DJ.
Hi.
If I close my Art Studio window, will I find my saved work later on?
Oh yes, as long as you saved it.
Okay, cool.
Yeah, and then if have multiple projects, you can just say open project, and then you can select which one you want to open.
Thank you.
Pleasure. Any other question? Okay, seems like everybody's on fire, so I'll see you guys tomorrow. Thanks for being with you and being so interactive. Thank you.
Thank you so much. See you tomorrow.